Hello, everyone. Welcome back. We are going to be continuing our game development project tonight. Excuse me. Congested throat a bit there. Let's check in with the kitties before we get started, though. We did have Sammy walking by the play area a moment ago, and we do have Sky taking up Ember's favorite spot there. We have to check that heating pad is drifting off the side of the desk. We'll fix it later. Let's see. Mason and Sherbet aren't present. There are a couple of spots that they could be hiding: foot of the bed or under the bed. I don't see them in any of their favored locations. We'll have to see if they show later tonight. Ember is on my lap. Hey there, Dark. Welcome, welcome. We're doing well today. We are getting back into our code project, trying to do this every day. Camera 1 back into general position, I think. So, we've been contending with a couple of memory leaks. It's largely down to being aware of the extra layer of the node tree in Godot. Anything that's a node exists in the world in some fashion. So it will be things like globals, where globals are cleaned up as kind of the root of the world. But there's also just regular nodes that we create over the course of it. And if those regular nodes aren't attached to a tree that gets cleaned up, then they're going to linger and potentially build up over the course of the session. And we need to minimize that sort of thing. So again, we're going to be dealing with lots and lots of entities on screen. We can show our progress here. We're zoomed way out. We are now using our new collision model, and we have our removal zone, our kill zone around the edge. If anything that's not the player touches that, technically it would get the player too. But it moves around the player. It always stays this far away. Anything that touches that gets removed. And if we look at our monitors here, where is it? Orphan nodes. Those are not going up. We are still creating lots of extra objects. The hope is that this doesn't grow. I am kind of concerned about this number being so high. I don't know why it is. We definitely don't have, nearly 1,500 objects worth of code, but we might be seeing things like the internal workings of stuff like physics engines manifest here. Just as important, our FPS is staying pretty steady. Let's change the template on the blobs just to get that rolling. We have monsters capped at 300 at the moment. We'll need to reload the scene. So we have blobs appearing. We're currently using this number as the counter for the number of blobs. Appearing 1-to-1 with the number of shots will eventually make the shots overcome them. I mean, if you want to volunteer that kind of information, feel free. I mean, I would suggest against putting any sort of personally identifiable health information in the channel. But otherwise, feel free. All right, let's speed up those blobs a bit. Spawn every half second. You know what? I'm gonna go 10 a second. not too surprising. It's remarkably likely that you have communities that are spread out that much. So we've got these propagating really fast. We have projectiles slowly culling them. And if we look at our monitor, we've got our FPS going. Objects are increasing steadily. We should hit a point of equilibrium with this, though. No orphaned nodes. That's good. So right about here is where equilibrium should be happening. Yeah. So this is like layered objects. We do get a bit of a frames per second hitch here. I like how they're having trouble closing in between collision with each other and player bullets. We might have to work on that. We might have to constrain their hitbox more. Because we have that just can we mess with this? Will that actually change it? Oh, it does. Neat. Okay. So this is a really weird situation. You see this red flicker around the edge of these circles. It might not be apparent, but trust me, there is a circle formed by red lines. And what that is their individual collision zones are bumping into each other enough and kind of pushing each other back and forth. What we may need is to add a little bit of randomized wiggle to the avoidance logic, because they're supposed to try to like brush away from each other when they move. We may have to expand that out, but this is kind of the movement where we want it. We could pull the circles in a bit, but that just makes the final like problem circle tighten up. So we're deviating. We still need to fix this memory leak first. Okay. So inside of a spawner, we just have the spawner node. And we need in the ready of it. Have a ready? We don't. Okay. We can just add a ready. Just go ready. Yes. So in the ready, hey there, Tyler. Welcome to the coding stream. Since this is the coding stream, there are the 3 different formats. So if you want to watch in wide form, you can do that as well. Okay, so Sammy has switched places with Ember now. We need a node under this that will house the words and things. Position modifiers. Our node as node is equal to node dot new. Our node dot name is equal to position modifiers. String is equal to, yes, hello, Sammy. I know. Did I stop petting you? What time is it for me? It's about 10 after 4 in the evening. This is when I have access to the most bandwidth. child position modifier node. Okay, so what this is going to do is when a spawner comes into existence, we're going to append a position modifier node. We're going to change it from a local variable, though. As a node. Okay, so what we're doing is we're creating it, but we're keeping a reference to it. We need that reference later. All right, Mud, thanks for swinging through. A brief but still appreciated strafing. Okay, so we have a position modifier node. And that should mean, okay, we already have all these position modifiers. We want to keep this node because we're going to want it later. So here we're going to go into the position modifiers, and we're going to do similar to this. We're going to add these in. Pull this back a little bit. We're going to remove this queue free. Okay, so we're getting each of the position modifiers. We're instantiating it, which means we have created a node. And then we say position modifier node. We're going to rename this. No, we have position modifiers. We'll keep the node. Add child. Instantiated position modifier. All right, what this will do is it's going to create a child node under this that contains all of the position modifier entities, which are nodes because we need them to be able to be packed scenes. Very congested throat today. So now we have a node that we can operate from, which means we don't need to instantiate these anymore. In position modifiers.get children. Dot get children. So we don't need to instantiate it anymore. We're just going to say position modifier, modify position. We don't need to queue free it. So this should work. Now all of these position modifiers are individual entities. But they're attached to the spawner node, which means I never need to free them. Once the spawner goes away, those position modifiers go away. Okay. So now we are going to go into our homing mouse. And we're going to take a position modifier. Yeah, we have spread shot. So we're going to take the count, and we're going to make this 9 to make 10 project. Make this 0. We're going to add an element and make that 9. Okay, so that's still flawed. We have some problem with our position modifier logic, which I believe is going to be a problem in Spreadshot. There's something that's wrong with how this is being handled. Because this should iterate over a collection of mob bodies and fan them out. Okay, and we're using degrees to radians there. Okay. So it comes in, we have mob bodies. There are 10 mob bodies. These are the projectiles. Hello, Ember. Ember is now switching with Sammy. Hello, sweetheart. Ember will come through and toast on my lap. The fact that Sky is where he is effectively denying Ember her favorite spot. Sky will come over and lay on her, but she won't come over and lay on him. And she only tolerates that from Sky. Microphone mute is misbehaving. Oh, I know why it is. There we go. I had it running, and if it's running, it prevents me from altering the sound devices. Okay, there are... Let's close that up. There's 10 bodies, yeah. Which means the angle slice, since we're using a 360-degree spread, doesn't make a lot of sense. Oh, yes, because we need to fan it out a little differently. If we're spreading out and say we have 2 projectiles, we don't want them to go up and down. We want them to go at 45. So we're bumping the number out so that whenever possible, one projectile goes straight forward. It is the classic Spreadshot problem. You want odd numbers. You always want odd numbers. Okay. So we're going through the number of... We're going through our spread angles. And we're starting at half of the angle minus 1. Or times minus 1. So things get weird here. Because we want it to be in that halfway part. So if it's 180 and there's 2, we're going to try to put them in the appropriate angles. But in this case, they're going to go up and down. So we say our spread, they would go up and down if we just use spread angle divided by 2. So that gives us 180, the spread angle divided by 2. Hey there, Ghost. I am probably making a real hash of explaining the Spreadshot logic because there's a problem with it and we need to walk through it. So we're kind of rubber ducking this. Anybody ever heard that? Rubber duck programming? The gimmick being that when you're looking through your code to find a problem or to understand it, you go through it as if you're talking to something. The part of the gimmick is often you have a rubber duck on your desk and you talk to the rubber duck. I can just talk to chat, but the naming convention holds. So if we had 180, so half of this, we're going to have negative 180 as the starting point. And we don't want the starting point to actually be 0. We don't want it to be that facing our direct target. I tend to ramble on as well, Jank. I tend to ramble on. It can be a good way to figure out what you actually think, though. Gets you out of that decision of the moment and makes sure that that you have some degree of certainty. It's not always the right decision that results, but at least you're more confident that it's the decision you wanted. And it can sound crazy to other people, so that can be a plus. Okay, so we have 180. We're going to divide that by 2. So we have a 90 degree. We have negative 90. So that's going to be, from our facing, that's going to be straight up. And then we're going to move it forward 1. Oh, that doesn't seem right. Hey there, welcome. So we have 32. We're going to move half of that. We're going to move 15 up. That's what the negative will do. We'll go 15 up. But then we're going to add 30 again. How does this work? I feel like I could rename this whole coding operation to why does this work? Okay, so we're moving by half spread angles. And we're reaching the end. Oh. Okay. What is our first eye? Negative 147. That doesn't seem right. Because angles... Oh, okay. Spread angle. Oh, okay, I was thinking of it wrong. I'm thinking of it wrong. We're making a game. We're making a game. This is zoomed way out, but it's a survivor-style game. So enemies will converge from the edges of the screen, and you accumulate various weapons that fire at intervals to remove the enemies, and you want to hold out as long as possible. There are a couple of things that I need to adjust yet, a couple of features, well, a whole bunch of features that aren't in yet. But we've got basic function in place. We have the little blob swarming. We have the edge of the screen, or the edge of the world zone that removes things. And then we have the ability to, move around. And you can't really see it, but there's a default projectile being fired. Part of it's not working. That's what this little dotted line coming this way is. And we get to the edge of the screen, and the blobs are getting removed. And thus more blobs start spawning. We keep moving, and every time we get to the center of a screen, the adjacent screens get populated. So as soon as I touch a red dot, that is the edge of a screen, or that is the center of a screen. So I hit that, and bloop, it fills in. Now, it's not exactly the red dot. It's just that's a good indicator of the center of a screen. If I come here, there's some rounding that put that other one in. But we can still get the edges. So this is where we are currently. We've spent some time getting the spawning in. We've spent some time getting all of this stuff working. Let's zoom in so you can see it better. The little blue circles are debugging stuff. Yeah. One projectile spawns properly. The other 9 do not, that's a problem. We're also going to have to come up with something that makes it so that simultaneous collisions are less likely or potentially not plausible, so that if, say, there's 9 projectiles in this little mouse ball there, if a blob touches it and would be removed, then it shouldn't remove all of those projectiles. It should only remove the number necessary to get rid of the blob. So I may have to do a check in the code that says do nothing if I don't have a target to hit, which should be straightforward. If the mice detect a collision at all, they just go away after sending a signal. So we have 10 bodies. We are taking the half of the spread angle, or taking the spread angle divided by number of bodies plus 1. That is our slice. So we start with our spread angle. We divide it by 2. So in this case, we have 180. We have negative 180. And then we have negative 90. That's where we're going to start. So we're starting like straight up. And we're moving 1 angle slice in. So we're about 60 degrees. And then what that should do is it's going to go until half. So it's going to go to the other side. And it's going to move in angle slice increments. Is that right? Yeah, it should be right. I think that's right. So we put a breakpoint here. We run the code. We have our first projectile coming up. We have our angle slice, so we're going to run until here. So now we should have angles to use. Yeah. So we can see it firing at negative 147, and it should end at about... that doesn't seem right. Our fan is a little off. So... Oh, no. Okay. That might be... Okay. That's a little off. That's a little off. We want this to be... We want that to be the last one. So I think this needs to be minus angle slice. So it looks like it's inclusive, which we don't necessarily want. There. Should have an angles to use. There we go. Well, now that... Oh, yeah. Here. Wrong breakpoint. It's a chat-heavy stream. Feel free to fire away if you got questions or comments or anything like that. Okay, that's about right. It's not quite right, but that should be about right. Oh, but these are integers. They shouldn't be integers. Okay, I think I know part of our problem. We're going to force body count to be a float. You have to watch out. So far, Godot will make assumptions. If you divide a float by an integer, it assumes that you want an integer, as opposed to you wanting a float, since In a lot of languages, it will take whatever you're storing it to, or it will take uh, whatever one of the objects is. If you divide an integer by a float, you get a float. If a float is involved, then you get one because it's a fraction. But that's not how we go here. This is weird. Why would this be? Do I have to do this? That doesn't make sense. How are we getting such even numbers? Because we start with 32.727. These are floats. They can't be such a nice number. Is our I? Okay. We need to do this a little differently. Let's reset to where we were just to be sure here. Okay, so we don't want I to actually be these angle slices. Float is equal to this. We don't actually need the end angle. We already have... Where do we get angle slice? There we go. We already have angle slice. Hey there, Barbed Wire. Good to see you again. We're doing math. Float is equal to starting angle plus I times angle slice. Should be 0 to body count. I think it's exclusive. We'll find out. Okay, there are 10 elements in the array. Oops. There we go. Okay, we have decimal values now. Ah, excellent. our angles were off before because what I have just discovered, and I probably could have found this if I read more into the basic iterators, but this produces ints and only ints, numbers without decimals. Because of that, I wasn't able to convert that into a float in the rest of the logic. It always ended up being an integer, so it was truncating values at every step. Okay. Then we're going to go through. We're going to say, okay, give me movement templates. We have 3 movement templates. We have our body to adjust. So we get our mob body. We get our movement template. So we have one of our projectiles. We have our movement template, which is target random. Okay. We get our target, and target is its random direction, or it should be generally. It has no object. It wants to go in that direction. So then we're going through for each body. We take the degree to use in radians. Has to be in radians. And we rotate that and put it in the new direction. I don't think we need this new old. We could probably clean this up. But it does save us one layer. We don't have to say target.target direction.rotated. I think it's largely irrelevant. We technically take up like 32 more bits or so in this function. Then we go in and we set the target, which goes in and says, okay, I have set target. And we're going to iterate over that. So we're going to go over each body and we're going to rotate it. And we're going to go over each one of that body's movement templates. So this movement template should be nearest mob. Target random mob. Okay. Target random mob should still be getting a entity properly because we have the target zone. So we get our target from that, and our target should have an entity at this point. Yep. As a target object, that was the direction to that target object. That direction is going to override the prior one. So we have a target mob, so we're going to use that. So we're going to rotate our direction into new direction and old direction. So it is adjusted. And then we set our target equal to the new direction, or the new direction of it, and we run that. We unpause. We are going to put a pass here. Okay. Is our mob bodies. So it has movement, a resultant target, 376927. They all still have the same movement. Something has gone wrong here. We are getting some sort of, I think we're getting some sort of by reference thing going on. So we're going to look at mob bodies each time we get to this. So the first one has movement, and the movement has target, negative 862. Go again. This one has movement and a target, which is the same thing. This is not surprising. All of them had the same target generated, and it's been shared with them. But we want to look at the other one has been rotated. It shouldn't be 862. But it is. It has been... No, wait. Let's do one more. Okay. This should definitely... This next one should definitely not be 862. But it is. It's not sticking. Look into our spawner. Do we have any... Target equal to... There might be a way to do a copy action on these, but... Or we are setting this equal to a copy. In this, we're iterating over them, and we're appending the movement templates. Create them, we append them, we create a movement object on the mob body. So mob body has movement templates each time. Then for each mob body, for the first one, we calculate the target. We get a copy of that target. We take that target and we shove it into the movement target of each subsequent entity. So they all have a copy of the target. So we are entering the first time. Go another. First one should be 86 or 679, negative 679. Go into our target. If we set the target, we just populate it. We can check if a target is already set by seeing if the direction is non-zero. Essentially, it's a vector return is effectively its value is 0 if it's 0, 0. And if it doesn't, if a vector is 0, 0, it is effectively not a vector in this case. It is not giving us a direction and magnitude anymore. Create a new target, we return that target. But they're not even moving at all. Interesting. So how about we remove the blobs again? So this removes the blobs from the equation. And we want movement move. Each time we're adjusting the velocity of the body to move. So we come in, the vector is 0. We're going to go over, this is random direction. Hey there. That was random direction, which now should get us a difference on body to move. Its velocity is still 0, 0. It's weird. Still 0, 0. And the third time. Oh. Okay. We want to get here. Doesn't change. Okay. Therein lies part of our problem. So the subsequent templates aren't doing anything. So let's zoom back in so we can see what I'm talking about. One. So we're spawning 10 mouse projectiles at once. These aren't moving. 9 of them aren't moving. But they should be. So I suspect we have a problem here, where we are setting the target. And that target isn't subsequently being propagated. So we're going to go in and we're going to get our mob body 0. I put it in a blank spot, and that is a no-op piece of code. So you never if I break on this line, it never happens. So you can't break on line 72 because it's empty. Okay, so we have our target. We have mob body 0's target. So it has a movement. Movement has a target. It's going to 999 there. So then mob bodies 1 should now have the same target. Yep, it does. So they all have the same target. Like, that is happening. So if we set, the target starts out as a new target. Well, thanks for swinging through, barbed wire. Glad you could be in again. Created our node. We add that. We have create the node. We add movement templates. We append the child for each movement template. For calculate target, we go through each movement template and we calculate the target by passing in the existing target and body to move. So we go here. So we have a target. We have an empty target. This is the first one. So now we get a new target and we have a direction. So if I do this again, we should have a different target now. Oh, no, there's no mobs. So same target. The mob one won't override the random direction one. Don't. We call move on them. And then a movement template. Let's sting. That's what's happening. They're not intrinsically calculating the target after we have set the movement target. We do this. Okay, they're spreading randomly though. That's not quite right. Let's get the blobs in there to be sure. It's recalculating the target. If I do move straight line, it just respects the target. If I do... What's it? Moving, targeting. You do random direction. Oh. Okay. Random direction is overriding the target. So the reason this is happening is we are passing along a pre-generated target. We want things to use that, but we want there to be a local target entity that can work. So the first time we go through, when the mob is created, we call calculate target on the first one in a group. So if there's 5 in a group, we call it on the first of the 5. And that one can generate a target. It should generate some kind of target. So subsequently, we then pass that target into the next ones. But target random direction receives that when it's calculating its own target and says, well, my target isn't set. So I am going to set my local target and use that. And I'm going to return that. But we don't want it to override that target. It has been given one. So each one should have the same target as the new one. So if we go into a movement template, like the default, we have set target. Target is equal to target.copy. Okay, we need to be calling set target on them. Movement has its target set. Ooh. We're getting into a code flow perspective here. So we don't want this calculating target. It has a target. So we don't want it recalculating it. We want this to propagate down. So I think movement objects need a set target. Target and then movement. Have a okay. Go through and we're going to get all of our movement templates. And we're not going to call move, we're going to call set target. Value.copy. This is probably redundant. Actually, no. Let's target is equal to value. We should be passing in a, like, we may want to pass in by reference. There we go. Okay, let's go into spread here. Let's just add more mobs, actually. 9, and the blobs will spawn at 0.1. So you can see each individual one isn't homing on a target. It's only the one that comes off of, like, there's a point straight out that is between two of them, is where it's actually aiming. It is the space opposite the open space. So if we add more projectiles to our homing mouse spawner here, again, it's opposite that gap. So let's potentially make it easier. Let's say 2. So only the one that's firing off at like the lower part of the T is the one that's targeted. We add 4, we'll get a we'll see more of a fan here. It's spreading so wide because the default spread is 360. Okay, we've got that working again. Now we need to go in, and our player scene needs to be a mob body. I think that's what we need. And that during the player process step, we do all this same stuff. Well, we do similar things. We're going to need like a state machine in this as well. How we do. Okay, we're gonna make a new player entity here. Targeting anymore, position, movement, mob catalogs. There we go, mobs. Make a new folder here, and we're going to call it player. This will actually help us for multiplayer, I think. Because, well, if we ever do that, making the player a mob, making the player an individual entity, well, a not a singleton, essentially, not a unique entity, means that we could spawn multiple of them. And if we make a movement logic, a movement template on it that says this is how you move, that gives us the opportunity to wire that movement into something else. So say the local player has a logic that says I follow the input on my client, and then those inputs are broadcast up to, say, like a server. Then the other players, the local copies of the remote players, their movement logic is server, give me positions only. Like, I don't send input. That could be cool. Okay, we have player, and we are going to inherit a scene. And we are going to save this scene as resources, mob, player. As the player body. So player body has all these parts now. Then we don't want the actual mob body. We are going to disconnect you, and we're going to connect another, which is an extension of mob body. It will inherit from that. It is a special class. It is a player. But it is still also a mob body. Follows all the same rules. For the time being, its process will be different. Say we look at blobs. Blobs have their interface. They have their targetable position, hurtable hurt. Let's just take all of this, which is largely the same for the player. Save that. Okay, now we're going to go into our original player code here. That never needed to be... was never needed to be exported. I want to change this to an animated sprite. So we need to figure out a good pattern for this. Okay, so it's going to be an animated sprite. We need new sprite frames. Go into this. We have... How do I change the name of this? We're gonna add some stuff first. So we have resources. We need art. The Nyanite itself, we're gonna open that, and they are 16 by 16. So we're gonna add you those 6 frames. There's our idle animation. 6 frames a second there. There we go. It's idle. Then we're going to add another. Call it walking. Going to go in. We're going to take that one. It is still 16. Kind of a hassle. Yep. Add those frames. They're automatic as well. Oh, okay. We have a default here. Okay. So then we have our process function, which we are going to take wholesale here, and our physics process. and we go into player body. Do this. We're going to get a bunch of errors out of this. So we have a velocity that we have set. We don't need the animate anymore. Velocity is equal to vector 2.0. Very explicit. We will move these somewhere else because these are good constants to have around. No, wait. Plus equals vector 2 dot up. Down. Dot left. 2 dot right. Okay, well that simplifies it. We have messages set up as to whether you're pressing like ASDF or the arrow keys, that kind of thing, for movement. A velocity is equal to velocity normalized. Say if not velocity. Yeah. See, it should be our sprite dot animation is equal to animation is a string name. Okay. Animation idle to idle. How do I get frames? Okay, I think this will still be the safest. Then we're going to set an animation idle. I'm going to want to set these somewhere else as constants because everything is going to use these. They don't move, they idle. If they move, they walk. No problem, Tyler. Welcome back. Animation. Walking. If velocity. Right dot. Okay, flip H is equal to true. I think there's a syntax for else if. We're getting there, Tyler. We are currently converting the player over to the new mob body pattern. So we're going to be creating a space for the player to exist in, and we're going to be adding the player to that at the beginning of the game. It's if. No. I get the idea of animated short, but I don't know what the prior two words imply. L if. There we go. Animation is equal to animation idle. If velocity. Equals velocity. Oh, there's a section for videos if you want to put it there. Assuming it's not something inappropriate. Okay, this thing is moving of its own accord currently. So for the time being, we're going to go into our game scene. We are going to add a new child to the game. It is going to be a collision zone. We're going to name it player collision zone. In its collision, it exists on the player level, but it looks for nothing. And then we are going to add a child to that. Is a player. And we're going to move the camera to a child of player. And we're going to remove the player node. So this should start it the same way as before. Or it'll hopelessly break it. Stop. Okay. Didn't hopelessly break it. Game object has a player. So the player is that. Why does the player not have a sprite? We're in process, so it's got to have a sprite. I'll have to take a look at that later, Tyler. My body code? Has sprite, and it has raycasts. Sprite didn't get set. Okay, why is sprite not set? Right there. Wait, debugger. No, not found. Sprite and raycasts. All right, let's add it after. On ready. We'll reorganize that later. New. Player collision zone. You need to add that as an export. Sort these accordingly here. Variable player collision zone. We could intrinsically set these as on readies, but that necessitates that we have their value. So we're still gonna manually set them like that. So we're gonna create a player object. Say player collision zone dot add child player. Our New child camera. We're gonna try this again. We're gonna add a camera under it. And we're gonna do Hey there, Colin. And we're going to add the player to this. Okay, we are going to lower that down. And we're going to change that to, for testing purposes. Still making codes. Trying to get a bunch of them together here so we can verify. Yep, collision is still working. Okay, we needed to use it as a scene here. Instantiating the player would make it different. So let's try this again. So we're gonna try to instantiate the player in ready. Packed scene. And we go into our game, and we should be able to go into player body. In export. How are you folks doing? Player body, and we put it as the player scene. So player is equal to player scene. Should be player body dot, but still. Instantiate. Player collision zone dot add child player, and then player linktr.add child camera 2d.new. Oh, welcome, folks. Hope you're having a good day. Yeah. I am pleased. Okay, that was the flaw, is that we had to instantiate the entity, which I think we're going to be able to do some more with that. Okay. So the reason that spawner get spawner might be having problems is that monster catalog, monster blob. So what we want is, where is it? Why is this not showing up? Yes, we're building a game, Irvin. This is a survivor-style game. We're still very early in the process. Part of this whole series of streams that we're doing is learning the coding engine that goes with this. We're using Godot engine. It's a Godot engine 4 version. I don't know precisely which one. Let's see here. 4.2.1. We're technically using the mono build of it, which allows it to interact with C# libraries, but we're not using that feature right now. Weird. Well, thanks. Let's take an opportunity. We'll check in with the cats. That cat, is it Mila or Milla? But that cat is Ember. The big fluffy one with the white stripe on his back is Sky. Then the two on the bed, one on a blanket and then on a pillow, are Mason and Sammy, respectively. And then in the little tree by a window, in the little house on it, is Sherbet. They are my 5 cats. I have an array of cameras to track them. Okay, so these templates are used to spawn them. And they give us a mob body. Long term, we're going to need to set it up so spawners can be instantiated temporarily and just spit out an entity. Could we use a mob factory for that? We can give it a mob. We can give it a mob template, and it'll spit out a mob body. Yeah, that should actually work. That should work. So, just like with a player, we're going to create a new resource. And it is a mob template. It'll be the player. This is a player template, which uses the player body Uh, pool type is... Okay, it's going to try to add the player to a mob pool type. So we're going to want to adjust this, actually. I really wish I could set this to something else. Can I? That's a flag. Look at our constants. Okay, okay. Hey there, Sniper. Welcome. We're in the process of converting the player entity over to the new collision model. We've mostly got it in there, but we're trying to make it so that we use all of the relevant systems. So I'm trying to figure out how to make it so that the mob factory and mob pool types will work for this. And I think I should be using this. I think I should be using this. This pattern. But symbol. Export flags, file, easing. Okay. What does the 2 mean? That is a... It's meant to translate it so I know which object to put them in when I create them. But I had it set up badly. This is how I think I can do it right. Yeah. Hey there, Pyro. Or Robot. So we should be able to do an export enum in the same way. So if I go into my mob template code, I can do export enum. It is going to be called mob pool type. So this might break stuff. It is a player bullet. Ah, yeah. I like this. Metal-like things. Pyro, metal-like things. Much of the body is derived from nanofluid. It's kind of grown like a artificially cultured organ. It still results in inorganic components like fiberglass like hair, metal outer shells, glass like stuff. It's a very specialized manufacturing process. Yeah, yeah. I like that. I like this a lot. It's so much better. Well, here. I always like the opportunity. It's fun to show off. So, eyeballs. The Nano core. Generally not visible internals, but the prototype model tends to get a little scuffed for entirely non-violent reasons. Okay, so our projectile is a player bullet. Our player is a player object. Then our blob is a enemy object, and it avoids the player in the enemy. It won't fully collide. Because people find cat ears cute. And it's important for a product to be cute and approachable. People are less likely to suspect it. I mean, more likely to buy it. Okay, so we have these in place. So now we're going to go into our mob factory. And we're going to go in, and we're going to add our mob pool type, which is in global nodes right now. I don't want it there eventually, but it is for now. Exactly, task. Foolproof marketing. So we're not going to use mob pool type. That is going to cause problems in just a moment. But our constants file should have what we need. Test. X is equal to X. Okay, thought so. No weaponry. Certainly not weaponry. Why would something cute and approachable have weaponry? Seems entirely unnecessary and potentially a violation of product laws. String to fall. Player enemy object bullet. Okay, we're going to be able to fix this here. So our mob types. So, just so. So. Okay. Have. Ah, boo. Okay, this is a failure surface. I don't like that, but it'll have to do. So you take the mob type, you take the collision mask, you stick them together, and you have a collision mask. We'll keep them that way for now. I played a D&D character like that once. Type. Global nodes. Okay, we're able to use collision masks because of that. Now this is mob type. Technically, a wall isn't a mob. Type flag. This is going to break some things, but we'll fix it in a minute. Okay, so if we go into a mob template, it is constants. Mob type flag wall. Fixing some things, fixing some things. Thanks for joining us, Pyro. Okay, now we double check. Still type enemy. Okay, okay. Player is type player. Glide has no avoidance logic. Projectile mouse is a player bullet type. How does it explode? I get rid of that. type is a mob. What is it called? A mob type. Can I not use a constant in a global? So we're exporting mob type. We should have access to this. Constant. No, okay. I'm just calling it a constant. Okay. Constants dot. Aha. Don't need to translate it. Enemy. Air bullet. Player collision zone. Type dot player load collision zone. All right, what did I? Oh, boop. Turns collision zone. Technically, this could just be a node, but they need to go in collision zones to work, so we're going to be specific. All right, what else is broken? Instance mob type enemy. Mob type enemy. Nice. Okay, now we can go into the player body. Edit in 2D. So we're going to have to adjust where the sprite is, but we need... Yeah. Flip horizontal. Where is it? Should be a flip horizontal somewhere in here. There we go. So this is making it so that the player is kind of off-center. So we're going to move the sprite in this case. Tricky. Collision zone won't work either. Like the actual shape won't necessarily work. It's the sprite extends beyond where the player is. Part of the problem is how the sprite is laid out. The body is a little to the left. So the collision zone extends out the front, but there's a safe zone behind. Offset isn't what we want. So what we'd like is to change the center. Like what point it flips on. It was -1. Yeah. I know how to solve this. In theory, I could move it further to the right in its animation. Yeah, I think I'm going to need to correct that. We'll get it, though. We'll get there. Okay. But yeah, look, we got it moving all around here. That's a good start. Let's change it so it's a mob factory call to create the player object. Another fun thing we can do is modulate the color a bit. It's just a complete tangent, but... Oh, no, it's not working. Oh, we're not creating it properly. That's why. We're kind of doing our own thing with this. So we have a player object. So then in the game, we have the player scene. We don't want a player scene. We want a mob template. So we need our game script. template. So then get that moment. Need our player. What are we doing elsewhere for that? Should be in spawner template. Export mob to spawn mob template. Yeah. Comment for now. Get that error out of the way, so hopefully it will let us update this. There we go. So then when we're creating the player is not player scene to instantiate. It is mob factory dot create a mob body from player template. By doing that, it should automatically be added to this collision zone. So then we add that to it. Didn't work. Oh. You need to move the player stuff down here. See, things like monster collision zone and whatnot, I want in the global nodes. These are things that everything can reference. But I want to move any sort of functionality, any sort of, do this thing out of global nodes. So the add things to the collision zones, I don't necessarily want in that logic. Those should be part of the relevant entities. Well, thank you, Jason. This is, if you haven't heard of it, this is called vtubing. Okay? Not only on YouTube, there are a lot of folks that do it on Twitch, but virtual YouTuber, This is a live 2D one, so this is technically just a flat image, but it's wired up like a 3D model, so you can get interior movement and the like. Okay, player object, player moves around. Yay! There's still targeting player. How does what work? The game or the model? Okay. So it starts out with an artist doing the image, of course, but they do it in a special way. The layering of the image isn't flattened. They keep all of the pieces when they make the image, and then they break it down into component parts and structure those so it looks like it does now, but it allows them to hide and slide things around with particular software. So I'm using a program called VTube Studio to render the model and to wire in camera tracking, so it moves around when I move around. The software that generally gets used for this type of model to render it is Live 2D Cubism, which is... it's a skill set to use that, let alone that the software is largely written in and documented in Japanese. Like, there's English interface, but it's translated. People have used stuff like this for game models. There are a lot of like procedural sprites, both paper doll style ones that are kind of siblings to this, but also fully procedural sprites, like the pixels are generated on the fly kind of stuff. But yeah, you could probably do 3D essentially in-game sprite models in a similar fashion. What we usually see though is that each like in this case, the ears would be an entity attached to it and they would just rotate accordingly. But that gives you some similar effects. There are some sprite editing programs on like Steam that do that sort of thing. Definitely different, but if you put the extra effort into it, you can do the same stuff. Okay, got the player added. Got so many things done now. There's still a lot of spaghetti code going on, but it can be. The cost of procedural stuff like that is upfront, is very upfront. Once you've got it rolling, though, it gives you a lot of flexibility for creating things. But it is more expensive than just frame-by-frame sprite stuff like what I'm using in the game. 6 frame a second, 16 by 16 sprites. Very straightforward. More complicated sprites with like individual limbs and collision zones and that kind of thing, much more complicated to make individually. All right, next thing. I think the next thing that we want to start doing is setting it up so it will create sprites on the fly, or projectiles on the fly. So quick break, and then I'll be right back to do that. Just a couple minutes. Settling back in. Okay. Let's see here. Again, we've got the player spawning. By doing this, we have the skeleton of things like couch co-op, multiplayer. Well, we have the start point for that, and that's that a player entity, something that controls the game state, can exist in multiple forms at once. Whether it means that all the players have to go away or similar, we have that basis. Welcome back. So now, what we want to do is start setting up the logic for triggering the creation of weaponry and attaching it to the player. Right now, that is handled automatically. Like, we just attach it right to the player. And that's not what we want. So instead, what we can start with is the idea of some sort of entity in the field that if you bump into it, it will trigger logic to grant that spawner and attach it to the player. Eventually, we're going to need what amounts to inventory management. I don't know that it will ever be presented to the user in an inventory-like form. But we're going to need some logic that says these are the weapons and these are the modifiers that have been attached to them. So we'll see. I've already been thinking of ways that we can further extend the logic that we're working with, but we'll see how that goes. Yeah, inventory systems have the wrinkle of both storage and representation, like linking things together. Okay. So it's not a monster. It is, again, these aren't mobs. I have railroaded myself into this position, but this is going to be an object. We're just going to call it item giver for now. It is going to inherit the mob body scene. Say mob object item giver. We're using something called Godot engine, Jason, and the scripting language is GDScript. Okay, it has the it has mob body, so we break that connection. Attach a script that is item giver body, and it extends mob body. All right, we now have an entity, what exists. Make new, it's going to be a resource, it's going to be a mob template. Pringles. A couple of Pringles are okay, but they very quickly start to taste off. Like, I remember them tasting better, so it's possible that it is a changing palate kind of scenario. It's possible that they changed the formulation of them, but they're not a top tier snack by any stretch for me. It's a very capable engine, Jason. It's also free. It's not like an open source thing, but it's a community managed and updated thing. It has been, I've heard it referred to as sort of like the blender of game engines. It's something that is slowly building up greater and greater functionality as it goes. Once it has been popped in such, Tyler. Giver uses an item giver body. It exists in object territory. It avoids nothing. They are salty. It's a little after 6:15. We're in the last hour. Okay, so now we go back to our game world. We create new child node, which is an object. That was the collision zone. Rename it. It is the object collision zone. Hey there, Scorpion. It does. So, you can probably hardly see it, but in the upper right corner of the screen, there's a little drop down that says mobile. You can pick which kind of compiler, like how it's going to compile it, to determine which platforms it would support. Mobile is pretty much try to make it as compatible as possible. If I recall, compatibility doesn't actually mean that as far as it is the most compatible. It's different than that, but I don't recall. Okay, we have object collision zone. Should be below the player, but above monsters and bullets. Bullets should be above monsters. Trail mix can be good. But, I mean, as one would expect, it depends on the composition heavily. All right, Tyler. Well, if you decide to head out, thanks for joining us. The game object and the Object collision zone is right there. And we're going to go into our global nodes and we're going to add move you above monsters. Objects should be below bullets. Object collision zone. Back into our game object, make sure, yep. Go into our script. Sorting them for consistency. Object collision zone. Should be live tomorrow. I don't know if I'm going to try to have the earlier stream. I'm trying to get into that habit, but we will have the coding stream. Trying to get those gaming streams in starting at noon, but otherwise 4 p.m. my time. Okay, so we have the object collision zone. And now when an item giver is spawned, it will be spawned into the object layer. Object collision zone. Its collision zone. It exists in the object layer. And it will check for player. We get folks in time zones all over the place. We have some folks that swing through where the stream starts just before midnight for them. Okay, so we're going to go into our item giver body, go into the sprite. We're going to add that new sprite frames. Sprite frames is up to 6, but we'll add a sprite in our other category, and we'll just use a purple ball. And we'll select the one frame, add that. Okay, so that's what an item giver looks like. It's, yep, okay. So that's all set. But we try to do this about 5 times a week. Might scale that up sometime in the future, but about 5 times a week. I do some research and some like preparatory work on this outside of stream, but otherwise all of the coding has been on stream. Which day are we on? This is day 26 of the project. So something akin to the 48th hour set of the project. No, that's wrong. 78th. Math. It's straightforward to use things. Folder structure and visual object structure is easy. If you're making a basic platformer or something like that, the systems for doing it are readily available. We're doing a lot of extra coding because we need increased efficiency when it comes to collisions. But you can have a few hundred things on screen, like a couple of hundred, and still maintain like 60 frames a second without having to make any adjustments. So you just, you slap physics bodies on the screen and they do what they do. Then blobs, code. Oh, that's right. Blobs don't do anything when they collide. Let's look at the projectile. Okay, it has a collide function. So we're going to go into our item giver. So item givers don't move, but they collide with the player. And they exist on the object layer. Yes, all the stuff is stuff that I've put together. A lot of it is a placeholder. I am going to use the blobs, but they're not an end state. That's when I say placeholder for them, they're not going to be like the default monsters. They're going to be one form of thing that's on screen. The little dude in the center, the player character is definitely going to be the player character. The background is not the end state background. Red tiles are screen world grid units. So if you stand on a red square, you're standing in the center of a screen. And the red borders are the edge of a screen. It's useful in some things. The wind-up mouse, that's going to be a weapon. How it works has not yet been determined. Like I said, probably going on about 78 hours at this point. Little less than that. If I like really dug in, I might be able to work faster. But when I say less than 78, there have been streams where it's mostly chat. So it's not like I'm working full tilt. Okay, if we go into the mouse and we say the mouse fires once every 5 seconds. And then in the item giver logic, we're going to go into... We're going to take this logic that adds the bullet spawner to the player. We're going to go into item giver. And when you collide with Fire dot. Oh, game development in general? I've dabbled in algorithms and some display and things like Unity, but I've never really kicked off a game dev project. This series has really been the start of it. Like, this is the first one I've actively set down. We're going to make a game. The glow effect? There isn't really a glow. Here, let me turn that off. So the little circles around them were that's debugging. That was for collision checking. If that's what you mean. Okay, so then if I collide with it, we add a bullet spawner. So then we're going to create another spawner in game for debug purposes. Spawner factory. Spawner. Okay, we need an object catalog now. Resource spawner template is a giver spawner. Hello there, welcome, welcome. Yeah, shaders are a whole, like, they're a thing of into themselves, like many graphical additions. That would be sit down and learn shaders. You know, that's independent of game dev. How are you doing, Marlet? So the giver spawner is going to take an item giver body. Oh, mob template. Item giver. It's going to spawn in 5-second intervals. It has nothing else. And then we're going to have an object. We're going to create a new resource. Is a object catalog. 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 Oh, okay. What is it called again? Is a catalog type. No, those are catalogs. A weapon catalog. Okay, it's just a resource. Yeah. Yeah. That's part of why they have like a very dark purple outline. I might make the outline black with dark purple being an interior color, but it's got a dark purple outline to it. Script is a object catalog. Yep. So we are using object catalog here. Extends resource. Because we don't ever want to have to reference objects by path. Like, you can reference things based on, hey, it's a globals catalogs, monster catalog. But I never want to do that because if I move the folders around, it'll explode. It's probably the thing to do there, Jason, is, do some tutorials, work on stuff for learning shaders. And then once you have something that you think works, try to plug it into other stuff. See if it does work, and then port it over to the things you want to use it for. Once you got it rolling, then you can skip steps. Object. Template is a, let's say, spawner template. So then I'm going to create a resource, which is a class name object catalog. And that means I'm going to create a new resource called an object catalog. Create. And it's in catalog, so it will be object catalog, resource file. Object catalog, we say the object giver, which we have a giver spawner. Then in catalogs, object catalog, and then I'm going to have an object that is like prepare the game state, which will load up like global catalogs, that kind of thing, and get them out of the game script. But for now, fat fingering this over and over. Brightening specific areas, I'm pretty sure you can use things like shaders to just like make the sprite. All kinds of stuff. It's a very versatile object and pattern. Look at our game object. We do game. We have, what's our object catalog? There we go. Take an object catalog right here. So catalogs, object catalog, to object catalog. So currently I've got, can't remember what the coding pattern is called. I think it's like a service model or something like that. Maybe not. But effectively, things like these catalogs are determined by what I load into another object. So right now, with the game object, I can go in and set different things. So I could change what is the player collision zone. I could change what is which monster catalog I'm going to use. So I could swap out things. Well, I mean, that's how you learn. You get out there, you try to do it, and likely you're going to do it wrong. And then you'll try it again and try it again. And either you'll decide, I don't really need that, and it's not worth, like, I don't prioritize the acquisition of the skill to do it over other things, or you'll get it right and you'll learn to do it. One way or the other. Object catalog dot item giver. Don't need self, we can just do add child here. Oh. Game object collision zone. Then we need in global nodes. This is not where it's going to be eventually, but we have mob type object node to object. Doesn't have movement. It doesn't have a target. I don't know, Jason. I haven't tried anything past that at this point. Well, I haven't gotten to anything like that. Okay, let's just get the object spawner working. So we're going to go in our weapon spawner. We can leave that. Those aren't being put in at this point. So we are just spawning givers. We're going to put those at 1 a second just so they show up. Which means we should get one almost immediately. Yep. Stop. Go. Okay, so mob body has a movement object, but it has no target. So then I calculate target, and Take the one mob body movement. You still have no target. Okay. So we need to make sure that calculate target results in a target period. Will this work? Weapon catalog should have weapon homing mouse. Yup. Weapon homing mouse. There's always stuff to refactor. Always other ways to do it. That would be very Art Deco, wouldn't it? Very World of Tomorrow. But would it be? Because the the futurism of the time tended to have a lot of that. You know, your gold swooshy accents kind of stuff. But cyberpunk usually implies that there's a trashier side to that tech. I wonder what it would look like. I don't know what the I don't know what the equivalent would be, because generally your future tech of that era is more, I don't know, ray gunny, maybe. Interesting thought, though, Lunar. Interesting thought. Why does it not recognize weapon homing mouse? Okay. Global nodes. Oh. Catalogs. Oopsie doopsie. Oh. Oh. Like a retro malt shop in a cyberpunk setting. What was that place that was? It was like a diner slash malt shop. Like they did the whole 9 yards. The orange, the red booth seats, the checkerboard floor. Thought it had like an R name. I can't recall. But yeah, that would be kind of interesting. You get the worn down cyborgs running a malt shop. Which is fun because a lot of times you get a really sort of like 80s, 90s futurism in cyberpunk settings. But then you would have that sort of retro look, then presenting a further retro look in it. Yeah, the jukebox was an antique and didn't work anymore, so it's got like future tech grafted to it. Okay, what's happening here is every time there's a collision with that bubble, it adds another spawner to me. All right, that is the precursor to weapon spawners. So we are going to go view free, which will get rid of the purple bubble. And then we will go into the game. A text. Okay, there will be one giver spawner spawned every so often on the same path that the blobs would spawn. Well, thanks, Jason, and thank you for joining us. And I do hope to see you next time. If you can't, I try to get at least my programming schedule up on YouTube channel in advance. Oh, there they are. So we touch this bubble, we should get a spawner. Yep, there's our mouse spawner. So now we touch another, and now we should be spawning twice as fast. One, two. 1, 2, 3. Blip, 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 blip. Now, I don't plan on having those bubbles be something in existence the way they are. Now, there will probably be some pickups, like, your classic XP point on the ground kind of thing. But we're going to wire that weapon logic into the level up logic. So we would have a listing of the upgrades that a player has received to each weapon in sequence, so that whenever a power-up is obtained, we can then recreate all the weapons that the player has and adjust them accordingly. So instead of just saying, okay, here is the mouse spawner forever, we're going to create a mouse spawner and we're going to adjust its template before spawning it. So we'll instantiate the template, fill in adjustments to it based on what we have, and then create the spawner from that template. So everything will have a starting point. Like a homing mouse always starts the way it is. So homing mouse spawner. So, it will always spawn this frequently by default. It will spawn this many. It will spawn this many clusters. All of that stuff will be baked in. But then when we start to adjust it, we can go through and make those changes. Like, oh, I have a speed multiplier that I'm applying. I'm going to go in and take the default and adjust that speed multiplier. Oh, I'm adding homing to it. It already has homing, but I'm adding homing to it. So it's move straight line now because I want to demonstrate the spread shot. But spread shot, I'm adding spread shot to it. Those kind of things can be added after, like, before we actually create the spawner. I add them to the template, and then we feed it into the spawner factory. So the next thing that we're going to do, for tomorrow is going to be setting up that process of, instead of touching the bubble gives me another instance of the spawner, we're going to have it where it recreates it and gives me a variant version of it. So, I touch a bubble and it all like randomizes some of the stuff that the homing mouse gets. Sometimes it will add homing movement on top of it. Sometimes it will add spread shot. Sometimes it will add other things, so that I can test that general process. Then we can start looking at adding modifiers, so that if I touch, like, let's say a red bubble, that it will append a modifier to the spawner that I have, or the spawners that I have. Something like that. We'll keep going down this road. So yeah. We're making a lot of progress. We have everything into the new physics system. We have... we fixed the spread shot. We've got the memory leaks currently under control for now. And we have... There was another thing that we did. I'll maybe remember later. But for next time, we're going to start further adjusting the spawner, or the weapon spawner system, so that we can start to get a handle on how the end result is going to be, how that system of composite weaponry is going to play out. Technically, how it's going to play out, not interface and visuals wise, that kind of thing. Okay. Well, again, I hope everybody had fun tonight. And if you did and would like to see more and haven't already, consider following, subscribing, commenting, all of that good stuff. It will hopefully make it easier for you to find my content in the future. But until then, I hope you all have a good night.